moment here. All right, now, do you have a TI 83 or 84? What
I
do you
have a TI 30XS. I don't know if that works.
Ooh. All right. Well, here's what I thought you might have, and you can tell me, hey, I don't have that. Do you have this?
I,
30, the 30XS is just a scientific calculator.
yeah, I don't have the 30.
Okay. All right.
TI
So let me,
83
so
one.
no, so that won't help here. Let's go back to the other screen. So okay, so we'll do one, and then maybe I'll recommend use a graphing tool for doing this faster, but you're gonna have to use quadratic formula for this. Okay, so first thing is to rewrite it in and hopefully you're seeing my screen with the
I do, I see it, yeah.
minus 5t squared minus 3t plus 64. This is in the form ax squared plus bx plus c, and you need to label the a, the b, and the c. And then the quadratic formula, I'll give it to you here. Minus b plus or minus square root of b squared minus 4ac all over 2a. So probably the hardest thing here is going to be for you to enter this into the calculator correctly. I'll try and help here. So it's good if you can do a few things as you go, like it's 3 plus or minus, and then minus 3 squared. It's really like this where you're squaring on the outside. But if you can do a few of the calculations as you go, it will help here.
Yeah, it goes quick, a little quicker.
Yeah, and then over 2a. Now, in terms of how you enter this into the calculator, here's how you enter it in the calculator. You need a parenthesis here. 3 plus square root. Well, yours is going to have like a square root symbol in parentheses. 9 minus 4 parentheses minus 5, 64. Close parentheses the square root, close parentheses for the numerator, divided by parentheses 2 times -5. So the hardest thing will be to enter this incorrectly. And then the thing that I don't know is it might be the minus. So you may have to enter this. And then I think you can just hit like the up arrow, or there's a way to recall the last line and then just go over and change that to a minus.
Yeah. Let's see. See, I'll divide it by, oh wait, I messed up. Okay, I think it's just best if I work on something else. And
well, let me show you the shortcut here. Yeah. You are going to want to have to, you are going to have to absolutely learn how to enter this calculator.
Here, I'm retrying it again.
But in terms of like how to get the answer, which I know is important because you're trying to get through topics, is to go to Desmos. Have you used that before?
Desmos, yeah, I know Desmos.
And you graph it and you get that point right there. Just the x value or the t value in this case. Okay, now yeah, so if you will want to practice this. I mean, you're going to get one on the test.
Yeah,
like that.
I'm like retyping it in. 4. Yeah, it said syntax error, so I think it's something
that means like there's a parenthesis in balance, or you're using subtractions instead of a negative. This format isn't good for me to help you with that, but now I'll just ask, does yours have a calculator there on the Alex window?
On Alex, yes, it does.
Okay, that would also be another option if you want me to talk you through how to use that one.
Yeah.
It's up to you. You have to share your screen whenever you're ready for us to look at another problem here.
Okay, let me just type. Yeah, okay, let me share my screen again so we can move on to the next one. Because that actually might be a little easier. Yeah, like this one.
Okay, so this problem here, you're setting the quadratic. Well, I've got to snip it in, but I guess I can show you how to use the calculator after I do that.
Okay.
So let me grab a snip here. All right, so let me share my screen. Okay. So they give you a lot of things that you don't need to read.
Right.
Okay. And this time though, they want to know when its height is 60 feet. So
Right.
in the previous round, we want to know its height was 0. Now we want to know its height is 60.
So we'll plug 60 in for H.
Yes. So so if you write the equation 156t minus 16t squared equals 60, your goal is to get all terms on one side of the equation. So I'm going to move everything to the right. And the reason is because I want the t squared to be positive.
Okay.
And then I'm going to subtract 156t. Okay. So this becomes 16t squared minus 156t plus 60 equals 0. And it's quadratic formula again.
Right.
So your A is 16, your B is minus 156, and your C is 60. Okay, so you just set up the quadratic formula. It's opposite of B, so it's 156 plus or minus the square root. Now this time I can't square that, so I'm going to write it in parentheses minus 156 squared minus 4 times A, that's 16, times 60C, all over 2 times 16, which is 32. Okay. So in terms of how you would enter it, I guess whenever you're ready, if you want to share your screen, I'll try and help you enter this into the calculator. You know, if you just want the answer, I can just graph it real quick. But I thought their calculator was more scientific.
Yeah, they have, it looks like this.
Okay, so let's do a parenthesis, open parenthesis, 156 plus.
Did I close it?
Nope.
No. Plus.
And then square root x there on the left.
Down.
I'm
squaring 156 or
no, go square root, the square root of x.
this
That one right there. Yep.
Yeah.
Okay, and then parenthesis, open parenthesis, another one, minus 156, close parenthesis, squared, minus 4 times 16. You can put that in parentheses, could close parenthesis, and then another open parenthesis, 60, close parenthesis. Okay. Now you somehow need to get out of the square root. I don't know if you can just hit to go to the right of the is the calculator, can the calculator get bigger? I don't remember.
Let's see.
Doesn't look like it. So you want to go, you're done with inside the square root. So you want to go right of the square root, maybe just put your cursor all the way to the right of it.
Like here.
Yeah, and close parenthesis. And then division bar. There you go, perfect. And then put 2 times 16. Or 2 parentheses 16 if you want.
Yeah.
Okay, so that should work. Oh no, so did you lose the so yeah, I can't. Oh yeah, you can recall it. So it's 9.35. And then go do a recall.
Oh.
I don't know if that what I was trying to get you back is to that thing that you just had.
It won't.
Maybe, okay. So I guess what I would do is copy and paste it before I hit enter in the calculator. But let me get the other answer, so I don't have to enter it again. You can see this is very slow, but you got to get
so is this answer incorrect?
No, it's only one of them.
Okay.
Because there's 2 places where it hits at 60. I'll show you that here in the graph. So I'll just snip that in. I mean, you got one of them.
Yeah.
But we need both. So let me show you that here. All right, so let me share screens. So you can see that one you just found was right there, 9.35, and then the other one is at 0.40. This thing goes up and comes down, but
So it was supposed to give me two answers because I have to
no,
do
no,
it with like the negative.
you had to go back and do the negative.
Negative instead of the
And
positive.
that's what I was saying. Like if you could copy it before you hit enter, then you can paste it back in and then just change the sign rather than have it entered again.
Yeah.
I mean, I always get frustrated when I have to redo something over and over again, but these are your answers. I don't know if the order matters.
Yeah, here, let's just see. So I would put like 9.35 comma.
Yes, yes, exactly.
40.
There's two answers. Yes.
Yeah, comma 40. It says you cannot put more than one. Here, I'll share my screen.
Okay, let me go back and look at it. Oh, you need the or. You need to use the or.
Okay.
Yeah. They're very particular about how they want their answers.
Oh yeah. Or 0. Okay, yeah, let's try that now. Okay, yes, that worked. There we go. Okay. Okay. I think I can try one on my own, but I'd rather just move on
Yeah,
to something
of course.
else.
Yeah, this is your time. Whatever you want to do.
Yeah.
It's just share your screen whenever you're ready, and we'll look at some more problems.
Yeah. Yeah, I guess this one, the expression function.
Yeah, no problem here. Yeah, so let me grab a snip here and talk you through these. All right, share screen. Okay, so it says find two functions f and g such that the composition gets you back. So what you're really looking for is like, what is the outside function or the outermost function? And that's the cube root of x. That's the outside function. And then the inside function, this one's nice because it's kind of already there. You can almost think of it like what's in parentheses.
Yeah.
Is 3x plus 1. So now when it's f composite g of x, that means f of g of x, and the g of x is your inside, and your f of x is your outside. So in terms of your answers here, 3x plus 1 cube root of x.
Oh, so it's just like you're breaking it up into
exactly. Like, yeah, that's the right way of right wording. Perfect there.
Okay. Okay, it's actually not bad. Okay. Yeah, so I'll share again really quick. There's this one.
Yeah, that's let me just actually write it down this time. Is it f? It's f of g of x again. Okay.
Yes.
All right, let me share my screen. So you may already have kind of in your mind what it is. So the outermost function or the outside function is the 6 power next to the 6, and that's the outside. And then the innermost function is the 1 minus 7x.
Oh, okay. So that's like all it is. It's just
that's all it is. So you just got to be careful about your order for this. Gotcha. It's backwards of the inverse. I'm sorry, backwards of the composition we did previously. So it's just like giving you the answer. How did you come up with it? Right. Okay. Yeah, so I guess, okay, yeah, the next one is a little different, but I kind of I'll let's see here. Yeah. Okay. Yeah, so this one has a few options for it. So that's why it says there may be more than one correct answer. Right. Which you don't care about. You're like, I just want the correct answer. But they're trying to say you know there's a few different ways that you could do this. Right. Let me share my screen here. All right. So like here's how I see it. I see that I look at like this thing that I'm putting in parentheses as your inside function. Okay. So let me do it differently. So the outside is x plus 5, and the inside, the thing that's going to go in the place of x, is that. Okay.
Okay.
Now the reason there's multiple answers, let me give you another way that you might see this.
Mhm,
You could see the inside function as 3x to the fourth plus 5,
mhm,
and then your outside function is just x,
mhm.
and that would take its place.
Okay.
So, but I think I would go with, I guess if I were me, I just I think the more clear one is the first one I did. So
Mhm,
the g of x is 3x to the fourth, and f of
mhm.
x is x plus 5. And then
Gotcha.
when you substitute in, it gives you the one that they're looking for.
4 in the beginning. Gotcha. Oh yeah, those aren't too bad. I guess I was just confused by like the wording of the problem like
Yes.
at
Yeah.
first and then. Okay, that makes a little bit more sense. Okay, perfect. Okay, let me find what else. Oh, yeah, so last time we had worked on the, I think it was the like finding the asymptotes. And
Yes.
then this one kind of confused me because there were multiple,
Yes.
so I got like stuck. I was like, oh, I don't want to like mess up my topics.
Understand. Yeah. Let me snip
Yeah.
it in here and we'll get this answered. So there can be more than one vertical asymptote.
Mhm.
Okay, which is I think what maybe was unclear here.
Yeah,
This one has 2.
right,
Okay, so the vertical asymptotes are the vertical lines.
right.
So where do you see the vertical lines? I see one at -2.
2, and then I think this is
Yeah, and
positive 4.
yeah, and so we want to use the and for that one. X
Mhm.
equals +4.
Positive 4, right.
There is, and so we'll say for the vertical, there could be more than one.
Mhm.
We just don't know until we see it. The horizontal, there's only ever one.
1, yeah.
So you only, I don't know, somehow to indicate that.
Mhm.
And the horizontal in this case looks like it's at 0. So we write y equals
Okay.
0.
Mhm.
Okay, now let's go to x-intercepts and y-intercepts next. We'll come back to domain and range.
Mhm. Right.
So does it cross the x-axis anywhere? It looks like it crosses right
Here, which is
right.
that's positive 3.
Yeah, so that's your x-intercept, and just double check that that's actually the one you're doing in case they flip it.
Yeah,
And then the y-intercepts where it crosses the y-axis looks like it's there at
positive 2.
yeah, +2. Yeah.
Mhm.
Okay, now for domain and range, domain's the easier one to talk about. The domain is corresponds to the vertical asymptotes. So that
Right.
the vertical asymptotes break it up.
Mhm.
So if you think of a number line and there's -2 and there's 4, those are the only excluded values.
Mhm.
So all those points, all those points, all those points.
Mhm.
So it's -infinity to -2, parentheses though, because they're not included, union,
Mhm.
-2 to 4, because it's all the area in between -2 and 4, union,
Mhm.
4 to infinity.
4 to infinity. Okay, okay, gotcha.
So the wherever you see a vertical asymptote, that's going to break up your domain.
Domain, gotcha.
Now, in the previous problems we did, the horizontal asymptote broke up the range,
Mhm.
but the difference is this one. See how this? I call this a snake,
Yeah,
which may be a bad reference in Arizona, but that's what I mean. It kind of isn't like it stretches the entire. It goes down forever, it goes up forever.
forever. Yeah.
So normally where it's broken up by this horizontal asymptote, but it goes right through it.
Mhm.
So there's no restrictions on the range. Like the range is good everywhere.
Right.
But if that part wasn't there, okay, then
Mhm.
it would be broken up by the horizontal asymptote. But it is so it's all real numbers. It's everything from -infinity to positive infinity.
Okay, gotcha. Okay, that makes a little bit more sense. Okay, I'll enter those values in. Excuse me. Sorry, I just like wrote these down because it's like easier and then I like type it in.
Yes, understood. I'll send this to you at the end as a PDF. Check your spam if you don't see it.
Yeah, no, I've received them. Yeah,
Okay.
I was looking at them today.
Great.
Yeah.
You do anything fun this weekend?
Not really, just relaxed and just worked on some math yesterday as well. Yeah.
All right. All right.
Yeah.
Well, whenever you're ready, go ahead and share the next topic or problem you
Yeah.
want us to look at.
Yeah. Okay, let me grab the next one. Let's see. Yeah, okay, I guess this one. Yeah, I can't like differentiate some of like the function problems because I feel like they all ask like the same thing sometimes.
Yeah.
And that's where I get stuck. So I guess like this one.
Okay. Yeah, this is a good one for us to look at. It's got some complexity to it. All right, so let me share my screen here. A moment. Here we go. Okay, so the first problem says, sorry about all the moving around. It says f over g, f divided by g. So in the most literal sense, you take f, which is 1 over x plus 4, and g, 8 over x, and you're like, I'm done, totally done, right?
Well, we have to switch the reciprocals.
Yeah, problem is you have to yeah, make some changes there. So division is the same as multiplying by the reciprocal. So it's 1 over x plus 4 times x over 8. And so now you think of that x plus 4 as being in parentheses. This is now x over 8 times x plus 4.
Gotcha. Yeah.
Okay. Now the domain, this requires a bit more work, and I'll try to give it to you as a recipe here so you can look at it again. But you have to look at both f and g and see if there's any restrictions.
Okay.
So when you go back to the original f and the original g, are there any restrictions? And you can never divide by 0. Divide by 0 is just really bad. So you set the bottom equal to 0, x plus 4 equal to 0. And that's x cannot be -4.
It cannot be negative. Yeah.
And then the next one you set x equal to 0, really not equal to 0, but x cannot equal 0 for g. So those are your two excluded points. So again, on that number line there, it's like everything but -4 and 0.
Okay, -4 and 0.
And sometimes it helps to draw it out to like not miss any of the intervals, because there's a lot of there's a lot of things you got to put in here to get the answer correct. 0 to infinity. So that's the first piece. There's a little bit more depending on what happens after you flip the reciprocal up here. After like there is one other step, but it does not come into play on this question.
Okay. So
that's
so our answer for the first one, is it just
it's that box up there?
Yeah, it's the x. Yeah, I see it.
Yes.
Okay. Yeah, I think that the top one is simple. It's just the writing, like the domain is where I get stuck.
Yeah.
So it's like a bit of a longer step. It's like more tedious. Okay, let's okay, let's see. What did I do? Yeah, it's x plus. It said something. Alex just said something about like a not quadratic. I don't know what I.
If you want to share your screen, I can try to talk you through whatever the issue is. Oh, so you're missing a plus inside the in the f over g. It should be 8 parentheses x plus 4. And then let me look at the next one there. Next one looks so no, so in the domain you've got like a you wrote a u, or there's there's two different union symbols.
Oh, instead of like.
Yeah. Yes.
It should be this one.
Yes.
Okay.
That looks good.
Yeah.
Please work.
All right, perfect.
Okay.
Okay, I guess we can try one more.
Yeah. All right, let me snip this. All right, share screen. Okay, so again, you just literally write whatever G is, 2 over X over F, X minus 1, okay? And then the X minus 1 is really X minus 1 over 1. So what you can do is multiply by the reciprocal.
Oh, right.
Like this, multiply by reciprocal. And then you treat everything as having parentheses.
Right.
So the top is 2, the bottom is X times X minus 1. Okay. So that is your
First
box. Yeah.
Oh, that's simple, right?
Yeah, not bad. Now the domain, again, you got to go back to the originals and look like, is there any exclusions? Like for f of x, there are no exclusions because x minus 1 is a line, no big deal. Okay. G of x, there is a problem. X cannot be 0. Okay, that's a problem.
Right.
All right. Now, so that's one issue. The next one is you have to go to this new f or G over f and look at it and see if there's any new exclusions. Okay, so there is a new exclusion there, x times x minus 1. So the problem is, yeah, it can't be, x cannot be 0 and x cannot be 1. So those are both excluded. So again, your number line here, you just look at those points and you're like, all right, it's everything in between them. So minus infinity to 0, union 0 to 1, union 1 to infinity.
Right, okay. Okay, that makes sense. Yeah, I guess drawing the number line kind of helps too.
Yes.
Yeah. Infinity. Okay. Okay. Okay, I guess we'll try one more and then see.
They always throw in a little wrinkle, every time. So
Yeah, they always switch it up sometimes, and that's what makes me nervous because you have to learn like the new rules or there's something different.
Yeah. This one's even more complicated, but it follows the same pattern. It's just there's more to do.
Okay, I'm writing it down.
All right.
Okay. So
all right. So the f over g, I'll write it up here on the top right. X minus 2 over x plus 6 divided by x over x plus 6. So again, you multiply by the reciprocal.
And then it's going to cancel out, I think.
Yeah, it does. And so this one, this one's got a few other things that we haven't seen before. Yeah, those cancel. So it's x minus 2 over x.
Right.
Yeah, that's your first sort of thing. But but hold on, but wait, there's a little bit more to do here.
Right.
You go back to the originals and you look at like, are there any problem areas? Are there any restrictions? And it's like, yeah, x cannot be -6 for either of them. Okay.
Right.
And notice that doesn't appear anywhere in this new one. But you do have to look at the new one. So you also have to set the new, whatever it is, f over g or g over f, you have to set the bottom also equal to 0 or not equal to 0. And you have you have to also look at that excluded point.
Okay.
So there's two exclusions at -6 and 0.
So it'll be -infinity, comma 6 or -6.
Yep.
And then union, and then -6, 0. Okay. Okay, let me just enter all that in. Okay, that one wasn't too bad, but yeah, I guess there was an extra step.
Yeah, because if you look at if you don't look at the beginning original ones, or if you just look at the new one, you end up missing one of the points,
which is like the 0, I guess.
Yeah.
Infinity. Okay, perfect. Okay, let me switch over to my review. I'm gonna for my exam and see what we can work on there.
Sounds good.
So I wrote down Okay, let's see. Okay, let's see, share screen. Yeah, it's like these ones I get a little confused on.
Okay, yeah, let me grab a snip. All right, share screen. Here we go. All right, so if you're seeing my screen, it says suppose that the function f is defined for all our numbers as follows. Okay, so the way to do this is you're actually first looking at this region over here on the right, and you literally ask yourself. So we're gonna look at f of -3. You ask yourself, is -3 less than or equal to -2? Okay, and you have to answer that correctly, but that's the step here, and the answer is yes, it is.
Yes, right.
Okay, so that means to use that first one. Now there's nothing to do, there's nothing to like input, but it's just that number.
Okay, yeah.
Okay,
So
now for the second one, it's the same thing. You ask yourself, is -2 less than or equal to -2? You know, it's a question.
and
It is this time because of that equal to. So since it's equal to, you just use the number that's there. There's nothing to do.
You're just
Yeah,
basically plugging in like is it like a true or false type
yes.
thing?
Yes.
Okay.
Now for the last one, you ask yourself, is 0 less than or equal to -2? And this time the answer is no. So you move on to the next one. Is -2, or I'm sorry, is 0 between 1 and -2?
And that's true.
Yes. So that means you use that one. That means you have to plug in 0. You plug in that 0 in for x, so it becomes parentheses 0 minus 1 squared, which ends up being 1.
1, right? Okay. Okay.
So you use the restriction part, and then you if whatever one is true, that's the one you use.
Okay. Okay, gotcha. That was just like a little review because I remember like working on it. I kind of saw it as like X and Y values, but like not really, but you're just making sure to see if like it's a true or false.
Yes.
equation.
Yes. And just be careful because like when it's negatives involved, it's easy to kind of like not do the right thing. Just be extra careful.
Okay, I'll share my screen again. I wanted to just like, I'm just gonna like ask if I did this correctly because there's like some I already attempted.
Okay.
So I want to like, I don't know if this has to be written. I guess I get confused when to use brackets and when to use parentheses.
Yeah, that's a good question to ask. Now, so your answer is correct. It is only decreasing from 2 to 4.
Okay.
So there's only one interval, so you got that part down. Sometimes there's more than one, and so at the maxes and mins, it's neither increasing or decreasing. Like imagine you're hiking and you get to the top of the mountain, you're not going up or down anymore.
Yeah, so it's just like, so 2 to 4.
Yeah, that's why it does not include the endpoints. Yeah.
Okay. And then I think I have a review for like 19. Yeah. Okay, yeah, this one we can. All
right, so let me grab a snip of this. Okay, for the real valued function, okay, two functions, find the composition f bubble g composition. So that means f of g of x.
Okay.
So we start with the inner function, g of x, that one right there. And then we put that into f of x. You always take the inside and put it into the outside.
Okay.
So that becomes parentheses, because we're squaring it, square root of x minus 6 squared minus 1.
Minus 1, okay.
Okay, so the square undoes the square root. So it just becomes x minus 6 minus 1, x minus 7.
Oh, okay. Okay.
So that one worked out nicely. Now for the domain, you, just like we did in the previous problems, you have to go back to the originals and look for any restrictions. Okay, in x squared minus 1, is there any restrictions? Like the two things we're looking for is division by 0, which there is none in the first one. And the second thing is the root of a negative number.
Which we don't have.
So in the second one we do, we have a root.
Root, okay.
Okay, so that with a square root, you have to set the inside part greater than or equal to 0.
0, okay.
So x can be greater than or equal to 6.
So
that's for F and G. So you always go back to the originals. These are tough questions. You have to go back to the originals, look for any restrictions. Then you look at the new one and see if there's any more restrictions.
Okay.
So the analogous problem is, I'm going to go back down to it, but the analogous problem was you look at F and G and you're like, okay, it can't be -6.
Right.
And then
we look at the new one.
They look at the new one. Oh, is there any other things to be worried about? Yeah, right there. So now for this problem, the originals, the x had to be greater than or equal to 6. And then the new one, there's no issues there.
Like yeah, because it's +7.
Yeah.
Okay.
So your domain is everything to the right of 6.
Everything to the right of 6.
Okay. So this time you're gonna have a bracket.
The inequality sign doesn't flip when you divide it by a negative.
You're adding 6.
You're adding. Oh yeah.
It does when you're multiplying or dividing by a negative.
Right.
Okay. So now because it's included, that's why I use a bracket, 6 comma infinity.
And that's all it is. It's not like going.
That's it. There's no restrictions.
Okay.
But you got to know where it starts. And so we have covered the two types that you will have issues with when you're dividing by 0 and then the square root.
Okay. And like for the x squared minus 1, that's like a positive one. That's why it's not like a restriction. Because
there's no restrictions on x squared minus 1. It's a quadratic. There's no like it's nice and smooth.
Right.
There's nothing awkward about it. But the root function, if you remember, it starts and it goes. Like it's got a place.
Yeah.
A starting point.
Right. Okay. Okay, that makes sense. Okay. And then I wanted to just check if this one was correct. I also.
Yeah. Go ahead and share your screen whenever you're ready.
Yeah. Let's see. Like these ones I still kind of get stuck on, but.
Yeah, so the graph on the left there, perfect. So the absolute max is 4. Now the absolute, I'm sorry, no. Boy, okay, so that let me grab a snip here. I'll have to make some comments. That might be useful later. Oh boy. Okay, so let's get my screen going. All right. Okay, now this is important here. I just saw this here. Assume that the dashed line is a vertical asymptote and the graph does not cross. So what this means for the graph of G, it means it goes up. It actually goes up forever.
Okay, and it's not going to go over the 5. Yeah.
No, but it does go up forever.
Okay.
So forever is infinity. And that means there's no absolute max when it goes up forever.
Because it goes forever. Oh.
Yes. Okay. Now, let me come back to the absolute min on that one. I should have done H first. So H is correct.
Okay.
That's the max and that's the min.
Yeah, now I see what I caught because it's an open circle at -5.
Yeah, so down here, you would think this is the absolute min.
Okay,
but it's not. It's not because it's not defined.
Okay.
And I don't really have a great analogy, but it's like a hole in the ground where you don't know where it goes. It just goes forever, falling forever. It's probably one of the worst.
So is the -2 here correct for the absolute minimum?
There is none. No. This is a relative minimum. Sorry, no. No, so the one on the left's an exception. The one on the right's the one you want to remember. It's got a max if it's truly defined there and it's the highest. It's a min if it's truly defined there and it's the lowest. If it goes up forever, it goes down forever. It does not have a max or min.
Or minimum.
If it's an open circle at a lowest point or highest point, it does not have a max or a min.
It's just gonna say none because it goes on
Yes.
forever. Okay.
Yeah, and there's nothing to find there. Even though like you think, oh, well, it's right there at the bottom. You know, it's like at the end of the rainbow, there's a pot of gold, but there really isn't. It's not there.
Gotcha.
Yeah.
Okay, thanks for clearing that up. That made a lot more sense. Okay, and then I think I'm gonna grab, let's see, how much time do we have left? We have like
seven minutes.
Yeah.
Try not to, I'm pretty strict with that because I do need a little break, but if you're in the middle of a problem, I'll try and finish it for you. So
okay, I'm just gonna like maybe look at like one more.
Of course, yeah. Maybe we'll get a couple more in.
Yeah. Okay, yeah, let's do this one. Just finding the range of a quadratic function.
Okay, yeah, this is good to do. You can, the shortcut here is to use Desmos to graph these if you need to get them done quickly. But let me show you how to do it by hand.
Okay, perfect.
Okay, so we're finding the range, which means we need to know whether this thing opens up or down. Can you tell me whether this opens up or down?
Down, because of the negative.
It opens down. So there's two types of ranges depending on whether it opens up or down. So if it opens up, it's the x coordinate of the vertex to positive infinity.
Gotcha.
And if it opens down, it's minus infinity to the x. I'm sorry, I guess these are the y. Sorry, the y coordinate of the vertex. We're doing the range y coordinate. So we really need the x and the, or I'm sorry, we need the y value of the vertex.
Okay.
So we need the y value of the vertex. So to get that, the x value is minus b over 2a.
2a. Okay.
So in your problem, it's minus 30 because and a is minus 3. Okay. Over 2 times minus 3. Was it 30 over negative 6? That's negative 5. Okay. Right. To get the y value, you put the x back into
the equation,
the function. Yeah.
Okay.
So you've got to find f of minus 5. Minus 3 parentheses minus 5 squared minus 30 times minus 5 minus 79. So it's a fair amount of calculations to do that. You may want to double check them on a test or a quiz to make sure you got them down right. Like I said, the other option is just graph it and find which I know you can't do in the test, but
yeah, we can.
Saves you time here when you're trying to get these things done. So it ends up being minus 4.
Yes, I got that as well.
Fantastic. So because it opens down, you're using this one. So the range is minus infinity up. That's a bracket. Minus infinity to minus 4. So parentheses always have, I'm sorry, infinities always have parentheses with them. And the numbers in this case will have a bracket. Okay,
that makes a lot more sense because I was working on this earlier and then I think I was messing up some errors just like with my signs, but this makes a lot more sense now. Okay. Okay, I got it. Thank you.
Cool. Whenever you're ready, you can share again.
Yeah, let's see. Let's try one more. Let's see. I think it was 30.
Yeah, this is good. There'll be
or I think it was this one. Like I got stuck on this one.
Okay, the vertical asymptotes, horizontal asymptotes.
Yeah, I still get just like iffy on them because I don't know.
All right. Yeah, so we did this I think 2 lessons ago.
Yes.
So the vertical ones are the more straightforward ones. You look at where you set the bottom equal to 0.
Right. So I remember that.
Okay, so you end up getting x equals 2 in that one. And you just got, I think you're just graphing there with that. Now the horizontal ones, this one's a little bit harder. There's 3 cases, and case 1 is when the degree of the numerator is less than the degree
of the denominator.
of the denominator, and this is
Right.
always y equals 0.
0, yes.
Okay,
Okay, I
and
think that
that's
was the rule I was trying to remember with the
yeah,
exponents.
we only saw them of this type,
Mhm,
but that will change in a future topic.
right. So the y is usually 0 when the exponent, so it's when the exponent is less than 1. So it's
Well,
Or
so
I
the
don't know.
degree of the numerator is 0
0 because there is no exponent
yeah,
there, right?
and the degree of the denominator is 1. It's the exponent.
And
It's like
that's y equals 0.
yeah, because you could in a future problem you get something like this,
Mhm.
where the degree of the numerator is 1
Mhm.
and the degree of the denominator is 2, and it's the same situation.
Okay, perfect. Okay, great, that cleared up my confusion. So I would just graph x equals 2 and then y equals 0.
Yes.
Okay, perfect. Okay, yeah, that was basically all my questions. I was thinking.
Sure, we got 2 minutes if you
Yeah.
are you sure?
Yeah, I'm sure.
Okay.
Yeah, that was
Okay. Perfect. Well, thank you for letting me help you, and good luck on your test or quiz, I think your exam, whatever you got. And
Yeah, thank you so much.
I appreciate you scheduling. I'll see you next time.
Well, I'll see you. Bye-bye. Thank you.
Okay, bye.